Imagine a machine so massive that just one of its tires stands 8 feet tall, taller than most men. Picture a tractor weighing 135,000 pounds, powered by a 16-cylinder engine producing 1,100 horsepower, capable of pulling an 80-foot wide implement across fields at speeds approaching 8 miles per hour. Most people would call that impossible. Most people would be wrong. This is the story of the Big Bud 16V-747, the largest farm tractor ever built in North America, a machine so extraordinary that it redefined what agricultural equipment could accomplish. Born in a small Montana town in 1977, this mechanical giant wasn't just big, it was revolutionary. And here's the kicker. It was built by hand in a modest manufacturing shop, custom ordered by farmers who needed something that simply didn't exist. This is the story of American ingenuity at its most ambitious, a tale of engineers who refused to accept limitations and built a legend one weld at a time. The story begins not in California's vast cotton fields, where the Big Bud would eventually work, but in Havre, Montana, a railroad town of fewer than 10,000 people, sitting just 30 miles south of the Canadian border. In the mid-1970s, Havre seemed an unlikely birthplace for agricultural history. The Northern Manufacturing Company operated there under the leadership of Ron Harmon, building custom farm equipment for ranchers and farmers across the northern Great Plains. The company had earned respect building the Big Bud line of articulated four-wheel drive tractors, machines considerably larger than conventional farm equipment, but still within reasonable proportions. The Big Bud 250 series tractors, introduced in the late 1960s, had proven themselves on massive Montana wheat farms, where Leonard Semenza operated 35,000 acres between Fort Benton and Chester. Those tractors were impressive, but they were nothing compared to what was coming. In 1976, the Rossi brothers contacted Northern Manufacturing with an unusual request. Elmer and Melvin Rossi operated approximately 20,000 acres of cotton farmland near Bakersfield, California, in the San Joaquin Valley. Their operation faced a persistent problem. California cotton fields required deep ripping to break up hardpan soil layers that restricted root development and water penetration. Conventional tractors couldn't pull deep ripper plows efficiently through soil that hard. The Rossis had been using Caterpillar D9 bulldozers for deep ripping, but bulldozers moved slowly, consumed enormous quantities of fuel, and weren't designed for agricultural work. The brothers needed something purpose-built, a tractor with enough horsepower to pull massive implements through rock-hard soil, articulated steering for maneuverability despite its size, and enough weight to maintain traction under extreme loads. They needed something that didn't exist. They needed Northern Manufacturing to build it. The hardpan problem in California's San Joaquin Valley resulted from decades of intensive cultivation that compacted soil layers 18 to 36 inches below the surface into cement-like barriers. Cotton roots couldn't penetrate these compacted zones, limiting their access to deep moisture and nutrients while making crops vulnerable to drought stress. Deep ripping shattered these hardpan layers, creating fracture zones that allowed roots to penetrate deeper and water to percolate downward instead of running off or pooling on the surface. The Rossis understood that improving soil structure through deep ripping would increase yield substantially, potentially paying for expensive equipment within just a few growing seasons. Caterpillar bulldozers could break hardpan, but their track design meant they worked at speeds of only 2 to 3 miles per hour, making field preparation agonizingly slow across 20,000 acres. The bulldozers' lack of three-point hitches and power takeoff systems meant they couldn't efficiently operate agricultural implements designed for tractor mounting. Maintenance costs on bulldozers running agricultural applications were astronomical because construction equipment wasn't engineered for the constant shock loads and abrasive conditions of deep ripping rocky soil. The Rossis had heard about Northern Manufacturing's reputation for building custom Big Bud articulated tractors that pushed boundaries beyond what major manufacturers offered. They knew Ron Harmon's shop had successfully scaled up tractor designs before, giving them confidence that Northern Manufacturing could engineer something unprecedented if properly motivated. The $300,000 budget the Rossis committed represented enormous faith in a small Montana manufacturer's ability to deliver a machine that existed only as concepts and rough sketches. Ron Harmon and his engineering team, led by designer Wilbur Hensler, accepted the challenge. The specifications the Rossis requested were staggering. The tractor would need 760 horsepower minimum, far exceeding anything Northern Manufacturing had built previously. It would require enormous fuel capacity for all-day operation without refueling. The chassis would need to support weights approaching 140,000 pounds when fully ballasted. Tires would have to be custom manufactured because nothing in production could handle the loads involved. The project would cost approximately $300,000, equivalent to well over $1 million today, making it one of the most expensive single pieces of farm equipment ever commissioned. But Harmon and his crew believed they could do it. They had the skills, the determination, and access to components that could be adapted for agricultural use. What they built over the next 13 months would become legendary. Construction began in 1977 in Northern Manufacturing's Havre facility. The engineering approach combined custom fabrication with adaptation of proven industrial components. Rather than designing every system from scratch, Hensler and Harmon leveraged existing technology from heavy equipment industries. The heart of the machine would be a Detroit diesel 16V-747 engine, a 16-cylinder, two-stroke diesel displacing 1,472 cubic inches, or 24.1 liters. This massive power plant, originally designed for marine and industrial applications, featured dual turbochargers and intercoolers, producing 760 gross horsepower in its initial configuration. Each of the 16 cylinders displaced 92 cubic inches, giving the engine series its name. The two-stroke design meant the engine fired every revolution rather than every other revolution like four-stroke engines, producing tremendous power from relatively compact dimensions. The transmission came from Twin Disc, a manufacturer of heavy-duty power-shift transmissions used in mining and industrial equipment. The 6-speed power-shift design allowed clutch-free shifting underload, essential for maintaining momentum while pulling massive implements. An 18-inch diameter torque converter smoothed power delivery from the engine to the drivetrain, preventing shock loads that could damage components. The articulated steering system used a center hinge that let the front and rear frame sections pivot relative to each other, providing surprisingly tight turning radius despite the tractor's enormous length. This design had proven itself on smaller Big Bud tractors and would scale successfully to the 747's proportions. The chassis itself represented masterful fabrication work. Welders built a robust steel frame designed to withstand forces that would twist conventional tractor frames like pretzels. The frame had to support not just the tractor's own weight, but also the massive pulling forces generated when dragging deep ripper implements through hard-pan soil. Engineers calculated that pulling forces could exceed 100,000 pounds under extreme conditions, enough to literally tear lesser machines apart. The Big Bud's frame featured heavy structural tubing and thick steel plates welded into a rigid yet flexible assembly that distributed forces across the entire structure. Every weld was critical. Every joint was reinforced. This wasn't mass production. This was hand-built American craftsmanship, applied to agricultural engineering's most ambitious project. Northern Manufacturing's welders understood that a single weak weld could become a catastrophic failure point once the Big Bud started pulling maximum loads through unforgiving hardpan. The articulation joint at the tractor's center represented particularly complex engineering, requiring massive pivot pins and bearing assemblies that could handle both vertical loads and the tremendous side forces generated during turns. Engineers specified steel plate thicknesses up to 3/4 of an inch in high-stress areas, creating a frame that weighed thousands of pounds before any components were mounted. The front frame section had to support the engine, transmission, fuel tank, and cab, while maintaining rigidity during the extreme twisting forces that occurred when one side of the tractor encountered obstacles or depressions. The rear frame carried the differential assemblies, hydraulic systems, and attachment points for implements, all while enduring constant shock loads transmitted through the drawbar. Fabricators used a combination of welding techniques, including heavy-duty stick welding for thick structural joints and precision MIG welding for critical areas requiring perfect penetration. Quality control meant inspecting every major weld visually and sometimes using dye penetrant testing to reveal hairline cracks invisible to the naked eye. The frame's design incorporated strategic flexibility that allowed it to twist slightly under load without cracking, absorbing shock forces that would shatter a completely rigid structure. Mounting points for the axles required massive steel brackets welded and bolted to the frame, capable of transferring 100,000 pounds of pulling force without deformation. The drawbar attachment point represented perhaps the most critical structural element, engineered as a massive forged steel assembly, integrated into the rear frame structure, rather than simply bolted on as an afterthought. Northern Manufacturing's craftsmen spent weeks on the frame alone, working from blueprints that Wilbur Hensler modified repeatedly, as engineering calculations revealed stress concentrations requiring reinforcement. The completed chassis weighed approximately 13,000 pounds before installation of drivetrain, hydraulics, tires, and cab components. Painting the frame required gallons of industrial enamel applied in multiple coats to protect against the corrosion that inevitably attacks agricultural equipment exposed to fertilizers, pesticides, and moisture. The frame's construction quality would prove itself over decades of operation, enduring forces that would have destroyed lesser designs within seasons. Modern computer-aided design and finite element analysis would later validate what Northern Manufacturing's experienced fabricators achieved through skill, experience, and calculated over-engineering, a chassis truly worthy of the world's largest farm tractor. Perhaps the most visible and impressive components were the tires. The United Tire Company of Canada custom manufactured 8 tires specifically for the Big Bud 747. Each tire measured 40.5 inches wide, 42 inches in cross-section, and stood 8 feet tall when mounted. These weren't agricultural tires scaled up. They were purpose-designed for this specific application, built to support enormous weights, while providing traction in soft soil without excessive compaction. When mounted as duals on both axles, the tractor's overall width approached 21 feet. The tires alone weighed hundreds of pounds each and cost thousands of dollars. Their specialized construction meant they couldn't be replaced with standard agricultural tires. The Big Bud would depend on United Tire Company's survival for its entire operational life, a dependency that would eventually contribute to the tractor's retirement decades later. The cab represented another custom fabrication challenge. Northern Manufacturing built an enclosed operator station with amenities unusual for farm equipment in 1977. Air conditioning kept operators comfortable during California's brutal summer heat. A heater provided warmth during Montana winters. The cab featured a swivel bucket seat for the primary operator, plus a buddy seat for passengers or trainees. Windshield wipers cleared the large glass windshield. An AM/FM radio with 8-track tape player provided entertainment during long days in the field, a luxury that seems quaint today, but was remarkable for agricultural equipment in the late 70s. Visibility from the cab was exceptional, elevated 14 feet above the ground and providing commanding views across vast fields. Hydraulic systems had to match the tractor's scale. The Big Bud featured a 150-gallon hydraulic reservoir, supplying fluid at 2,000 pounds per square inch through a pump flowing 60 gallons per minute. Those specifications meant the tractor could power enormous implements with multiple hydraulic cylinders operating simultaneously. The hydraulic system controlled the articulated steering, powered remote cylinders for implement control, and operated auxiliary functions. Reliability was paramount. Hydraulic failure in the middle of a field, pulling a massive implement, could leave the tractor stranded and create dangerous situations. The hydraulic pump itself represented industrial-grade equipment adapted from construction machinery, driven directly off the engine through a power takeoff connection that ensured constant pressure regardless of ground speed. Northern Manufacturing installed multiple filtration systems throughout the hydraulic circuit, recognizing that contamination from dirt, metal particles, or degraded seals could cascade into catastrophic system failures. The articulated steering demanded precise hydraulic control, using dual cylinders mounted across the center hinge that could pivot the front and rear frame sections through angles approaching 90 degrees for maximum maneuverability. Engineers calculated that steering cylinders needed to generate forces exceeding 20,000 pounds to turn the loaded tractor against soil resistance, requiring cylinder bore diameters of 6 inches or more. The hydraulic reservoir's 150-gallon capacity wasn't just about volume. It provided thermal mass that helped dissipate heat generated when hydraulic fluid passed through control valves and actuated cylinders under high pressure. Heat exchangers integrated into the hydraulic system used engine coolant or ambient air to maintain fluid temperatures within acceptable ranges, preventing the viscosity breakdown that occurs when hydraulic oil overheats. Remote hydraulic connections at the rear of the tractor allowed operators to control implement functions like raising and lowering ripper shanks, adjusting working depth, or activating supplementary cylinders without leaving the cab. The system incorporated pressure relief valves set to open at 2,200 pounds per square inch, protecting components from dangerous pressure spikes that could rupture hoses or damaged seals. Hydraulic hoses themselves were heavy-duty industrial grade, with steel-braided reinforcement, rated for pressures well above the system's operating range to provide safety margins against burst failures. Implement manufacturers designing equipment for the Big Bud had to engineer their hydraulic cylinders to match the tractor's 1,800 psi system pressure, creating compatibility challenges, since most agricultural implements operated at lower pressures. The hydraulic fluid capacity meant oil changes required specialized equipment and careful disposal procedures, as 150 gallons of contaminated hydraulic oil represented significant environmental hazard if improperly handled. Maintenance protocols called for hydraulic fluid sampling and analysis every 500 operating hours, checking for metal particles, water contamination, or chemical breakdown that could indicate impending component failures. Northern Manufacturing specified premium hydraulic fluids with anti-wear additives and viscosity stabilizers, formulated to maintain performance across temperature extremes, from Montana winters to California summers. The Big Bud's hydraulic system ultimately proved one of its most reliable subsystems, operating for decades with relatively few failures, despite the enormous forces and continuous duty cycles it endured. Modern agricultural tractors have adopted many hydraulic technologies, pioneered or proven on machines like the Big Bud, including closed center systems, electronic pressure control, and high-flow auxiliary circuits that enable increasingly sophisticated implement automation. The fuel system reflected the tractor's appetite for diesel, a 1,000-gallon fuel tank, larger than many automobiles' entire fuel systems, provided all-day operation without refueling. At typical consumption rates approaching 3/4 of a gallon per acre, that fuel capacity allowed the Big Bud to work over 1,300 acres before needing diesel. The tank's size also contributed significantly to the tractor's weight. 1,000 gallons of diesel fuel weighs approximately 7,000 pounds alone, adding substantial ballast that improved traction. Construction took approximately 13 months, with the Big Bud 747 finally completed in January of 1978. The finished machine measured over 27 feet long, nearly 21 feet wide with dual tires, and 14 feet tall to the top of its cab. Its operating weight approached 135,000 pounds when fully ballasted with fuel, fluids, and implement attached. For perspective, that's heavier than a fully loaded semi-truck. The tractor was so large that transporting it required special permits and careful route planning to avoid low bridges and narrow roads. When Ron Harmon and his crew finally fired up that 16-cylinder Detroit diesel for the first time and heard its thunderous rumble, they knew they had built something extraordinary. The Big Bud 747 wasn't just the biggest tractor Northern Manufacturing had ever built. It was the biggest farm tractor anyone had ever built. Before shipping to California, Northern Manufacturing displayed the 747 at the California Farm Equipment Show in Tulare in February of 1978. The massive tractor drew crowds of farmers, engineers, and curious onlookers who could barely comprehend its scale. Standing next to conventional tractors, the Big Bud looked like a different species entirely. Its 8-foot-tall tires dwarfed grown men. Its cab sat higher than pickup truck roofs. The Detroit diesel's 16 exhaust stacks, 8 per side, rose like organ pipes behind the cab. This wasn't just impressive, it was almost frightening in its enormity. Could something this large actually work effectively in agricultural applications? The Rossi brothers were about to find out. The Big Bud arrived at the Rossi brothers' operation near Bakersfield and immediately went to work doing what it was built for: deep, ripping cotton fields. The tractor pulled massive ripper implements, featuring multiple shanks that penetrated about 3 to 4 feet into the soil, shattering hardpan layers that conventional equipment couldn't touch. The 760 horsepower Detroit diesel didn't just pull these implements, it pulled them at speeds that seemed impossible for equipment that size working ground that hard. The articulated 4-wheel drive system provided exceptional traction, distributing pulling forces across 8 massive tires that maintained grip even in challenging soil conditions. The Big Bud's work transformed how the Rossi brothers approached field preparation. What previously required multiple passes with bulldozers moving at crawling speeds could now be accomplished in single passes at reasonable working speeds. The tractor's productivity was staggering. Deep ripping that would have taken weeks with conventional equipment was completed in days. Fuel consumption per acre, while substantial in absolute terms, was actually reasonable when compared to bulldozer operations that burned even more diesel while accomplishing less work per hour. The Big Bud proved its worth immediately, justifying its $300,000 price tag through pure productivity. The tractor's ability to pull deep ripper implements at speeds of 4 to 6 miles per hour meant it could cover 60 to 90 acres per 10-hour workday, compared to the 20 to 30 acres that Caterpillar bulldozers managed at their crawling pace. Cotton planting schedules demanded that field preparation be completed within narrow weather windows, and the Big Bud's speed meant the Rossies could finish ripping operations before optimal planting dates passed. The 760 horsepower Detroit diesel consumed approximately 3/4 of a gallon of diesel per acre during deep ripping operations, translating to roughly 75 gallons per 100 acres worked. While that fuel consumption seemed enormous compared to conventional tractors, using 15 to 20 gallons per 100 acres for normal tillage, it represented significant savings over bulldozers that burned nearly 1 gallon per acre while working much slower. The Big Bud's fuel efficiency advantage came from its purpose-built design that optimized power delivery for agricultural work rather than adapting construction equipment to farming tasks. Operating costs per acre dropped dramatically once the Rossies factored in reduced labor hours, faster field preparation, and improved crop yields from better soil structure. The deep ripping the Big Bud accomplished created fracture zones in the hardpan that remained effective for multiple growing seasons, meaning fields didn't require annual deep tillage once the initial work was completed. Cotton yields increased measurably on deep ripped fields as roots penetrated deeper into the soil profile, accessing moisture and nutrients unavailable in shallow, compacted soil. The Rossies calculated that yield improvements of just 10 to 15% across their 20,000-acre operation generated additional revenue exceeding $100,000 annually, allowing the tractor to pay for itself within 3 to 4 years. Maintenance costs on the Big Bud proved surprisingly reasonable despite its massive scale, as the robust construction and quality components required less frequent repair than the abused bulldozers it replaced. The Detroit diesel engine's two-stroke design meant simpler maintenance intervals with fewer moving parts than comparable four-stroke engines, though it demanded precise attention to air filter changes and lubrication schedules. Operators reported that the Big Bud's enclosed air-conditioned cab made long workdays far more tolerable than operating open-air bulldozers in California's brutal summer heat exceeding 100 degrees Fahrenheit. The tractor's articulated steering proved essential for turning at field ends despite pulling 80-foot-wide implements, allowing efficient operation even in irregularly shaped fields with limited headland space. Neighboring cotton farmers throughout the San Joaquin Valley took notice of the Rossies' dramatically improved field preparation efficiency, with several inquiring about commissioning their own super tractors from northern manufacturing. The Big Bud became something of a local celebrity, with agricultural publications featuring it in articles about innovations in cotton farming and deep tillage technology that were transforming California agriculture. The tractor worked the Rossi brothers' California cotton fields for approximately 11 years, accumulating thousands of operating hours, while proving the viability of purpose-built super tractors for specialized agricultural applications. During that period, the Big Bud became something of a legend in California agriculture. Farmers throughout the San Joaquin Valley knew about the massive tractor working near Bakersfield. Equipment operators spoke about it with a mixture of respect and amazement. The Big Bud wasn't just a tractor. It was a demonstration of what American manufacturing could accomplish when ambition met engineering skill, and someone was willing to pay for capability beyond industry standards. After leaving the Rossi Brothers operation, the Big Bud found a second career in Florida with Willowbrook Farms of Indialantic. This vegetable farming operation also needed deep ripping capabilities for soil preparation. The Big Bud adapted well to Florida's different agricultural environment, proving its versatility beyond California cotton fields. However, by the mid-1990s, the tractor sat idle more than it worked. Age was taking its toll. Replacement parts for the Detroit diesel were increasingly difficult to source, and those massive custom tires showed wear that couldn't easily be remedied. The Big Bud's future looked uncertain until 1997 brought it full circle back to Montana, back to within 60 miles of where it was born. Robert and Randy Williams, brothers farming in Big Sandy, Montana, purchased the Big Bud and brought it home to Chouteau County. The Williams brothers saw potential where others saw an aging relic. During the winter of 1997 to 98, they conducted a complete rebuild of the massive tractor. The Detroit diesel received significant upgrades, with horsepower increasing first to 860, then to 960, and eventually to an incredible 1,100 horsepower. The engine modifications included enhanced turbocharging, improved fuel injection, and internal strengthening to handle increased power outputs. The hood was repainted brilliant white, creating dramatic contrast with the tractor's signature red frame. Chrome exhaust stacks replaced the original pipes, giving the Big Bud a show-quality appearance. New graphics announced the tractor's heritage and specifications. The Williams brothers put the rebuilt Big Bud to work, pulling an 80-foot-wide field cultivator across their Montana grain fields. The numbers were almost unbelievable. At working speeds approaching 8 miles per hour, the Big Bud covered 1.3 acres per minute, 78 acres per hour. A 10-hour workday meant almost 800 acres cultivated. For perspective, conventional tractors might cover 30 to 40 acres per hour with smaller implements. The Big Bud's productivity was literally an order of magnitude greater. The sound of that 1,100 horsepower Detroit diesel working under load became familiar across Chouteau County, a deep, rumbling thunder that announced the Big Bud's presence from miles away. But nothing in agriculture lasts forever, and by the mid-2000s, economics and technology were working against the Big Bud. The Williams brothers transitioned toward no-till farming practices that eliminated the need for extensive tillage. No-till agriculture preserves soil structure, reduces erosion, and cuts fuel consumption dramatically, but it also makes massive tillage tractors obsolete. Simultaneously, the United Tire Company of Canada, manufacturer of those critical 8-foot-tall custom tires, went bankrupt in 2000. Replacement tires became impossible to source. The Big Bud's tires would eventually wear out, and when they did, the tractor would be grounded permanently. Rather than work the machine until its tires failed, the Williams brothers made a difficult but wise decision: retire the Big Bud in July of 2009 while it could still operate, preserving it for future generations, rather than working it to death. The Big Bud's retirement didn't mean abandonment. The Williams brothers understood they owned a piece of American agricultural history that deserved preservation. The tractor was initially displayed at the Heartland Acres Agribition Center in Independence, Iowa, where thousands of visitors marveled at its massive proportions. In 2014, it was moved to the Heartland Museum in Clarion, Iowa, where it remains today on indefinite loan from the Williams brothers. The museum constructed a special building to house the enormous tractor, protecting it from weather while allowing visitors to appreciate its scale. In July of 2020, the Big Bud received new Goodyear tires to replace its aging original tires, ensuring it could still be moved and potentially operated for special demonstrations. The Big Bud 16V-747's legacy extends far beyond its impressive specifications and working career. It represents a unique moment in agricultural history when custom fabrication shops could still compete with major manufacturers by building specialized equipment for specific applications. The Big Bud proved that bigger could actually be better when conditions warranted scale, that one massive tractor pulling one enormous implement could outperform multiple smaller tractors pulling smaller implements. That lesson influenced the development of modern super tractors from manufacturers like Case 1H, John Deere, and New Holland, whose largest production models now approach 600 to 700 horsepower. While still smaller than the Big Bud, these modern giants owe their existence partly to the proof of concept that Northern manufacturing provided in 1977. The Big Bud also demonstrated the importance of supporting infrastructure. The tractor's eventual retirement resulted partly from the bankruptcy of its tire supplier, illustrating how even the most capable machine depends on parts availability and service support. That lesson resonates today as agriculture grapples with right-to-repair issues and concerns about parts availability for increasingly complex equipment. The Big Bud worked for decades because it was built simply enough that skilled mechanics could maintain it using available parts. Modern tractors, loaded with proprietary electronics and software, may not prove as durable or serviceable over comparable time spans. When United Tire Company of Canada went bankrupt in 2000, the Big Bud's 8 custom tires became irreplaceable antiques that would eventually wear out with no source for new rubber. The tractor's dependence on a single supplier for critical components highlighted the vulnerability of specialized equipment that couldn't use off-the-shelf parts available from multiple manufacturers. Detroit Diesel's 16V-92 engine, while no longer in production, benefited from decades of widespread use in marine, industrial, and trucking applications that created robust aftermarket parts supplies. The Williams brothers could source engine components, filters, and rebuild kits from multiple suppliers serving the heavy equipment industry, keeping the power plant operational long after Detroit Diesel discontinued the model. The twin-disc transmission similarly enjoyed long-term parts availability because mining and construction industries continued using compatible equipment for decades. Northern Manufacturing's decision to build the Big Bud using adapted industrial components rather than designing everything custom proved strategically brilliant, ensuring that most systems could be maintained using parts channels that would survive for generations. The contrast with modern agricultural equipment is stark. Tractors now contain dozens of electronic control modules with proprietary software that only authorized dealers can diagnose or repair, creating dependencies that prevent farmers from maintaining their own equipment. Manufacturers increasingly use software locks and encrypted systems that prevent independent mechanics from accessing diagnostic information or installing replacement parts, forcing farmers to rely on dealer networks that may not exist in remote rural areas. The Big Bud's mechanical simplicity meant that competent diesel mechanics with welding skills could troubleshoot and repair nearly every system without factory support, manufacturer authorization, or specialized diagnostic computers that cost tens of thousands of dollars. Today, the Big Bud 16V-747 stands as a monument to American agricultural ambition and engineering capability. Visitors to the Heartland Museum in Clarion, Iowa, can stand beside those 8-foot-tall tires, peer up at the cab 14 feet above the ground, and try to comprehend the scale of this magnificent machine. Enthusiasts create detailed scale models celebrating the Big Bud's iconic design. Photographs of the massive tractor pulling its 80-foot cultivator across Montana fields circulate endlessly on social media, introducing new generations to this mechanical marvel. The Big Bud proves that sometimes, in certain circumstances, for specific applications, bigger really is better. It stands as testament to what skilled craftsmen can accomplish when clients demand the impossible and engineers refuse to accept limitations. The 16-cylinder Detroit diesel that powered the Big Bud is long gone from production, a victim of emissions regulations that make two-stroke diesels unacceptable in modern applications. The United Tire Company that built those massive custom tires vanished into bankruptcy. Northern Manufacturing closed its doors decades ago. The agricultural practices that demanded deep ripping have largely given way to conservation tillage and no-till farming. The world that created the Big Bud 16V-747 no longer exists, but the machine itself endures, preserved and celebrated, a reminder of an era when American manufacturing built whatever customers needed, regardless of how ambitious the project seemed. It stands as proof that the impossible is just the difficult waiting for someone brave enough to try. The Big Bud represents the last generation of agricultural equipment, built before computer controls, emission systems, and corporate consolidation homogenized tractor design into standardized platforms manufactured by multinational corporations. Standing in the Heartland Museum, this mechanical giant tells a story about American ingenuity, craftsmanship, and the willingness to tackle engineering challenges that seemed insurmountable, to create solutions that didn't exist in any catalog. The tractor's survival ensures that future generations can witness physical evidence that small-town fabrication shops once competed with industry giants by building custom machinery that pushed technological boundaries beyond what mass production could achieve. Have you ever seen the Big Bud in person at the Heartland Museum? Have you operated one of the massive modern tractors that followed in its tire tracks? What's your favorite story about agricultural equipment that redefined what was possible? Share your thoughts in the comments below. We'd love to hear from fellow enthusiasts who appreciate American agricultural history. And if you enjoyed learning about this legendary machine, subscribe for more stories about the equipment, engines, and innovations that built American agriculture and continue shaping how we feed the world. The Big Bud 16V-747 may be retired, but its legacy rolls on across every field where massive tractors pull massive implements, proving that sometimes the biggest challenges require the biggest solutions.